Let's do section 10.4, page 515, exercise 40, which reads, determine the convergence or divergence of the series. Identify the test or tests you use. So for exercise 40, we have the series from n equals 1 to infinity of n factorial times e to the negative n. Now, I like to use the ratio test. So I'm going to start with that, and that tells me that I'm going to take the limit as n goes to infinity of the n plus 1 order term divided by the nth order term. So I'm going to have the limit as n goes to infinity of n plus 1 factorial times e to the negative n plus 1, and I'm going to divide that by n factorial times e to the negative n. Now, what almost always happens when I use the ratio test is I can do some simplification. I can do some canceling. So let's look at that. So I'm going to have the limit as n goes to infinity. Now, as we saw in a previous example, n plus 1 factorial is equal to n plus 1 times n factorial. So I can cancel out the n factorials, and I'm just going to have n plus 1. And then I'm going to be able to cancel all of the e to the negative n's in the denominator with the e to the negative n's, e to the negative n in the numerator, and I'm just going to be left with e to the minus 1. Now, when I evaluate this limit, I'm going to end up with infinity. And remember that the whole point of the ratio test is that this limit is equal to L. And in this case, L is going to be greater than 1, which means that the series diverges. Now, there are other ways that we could calculate this instead of using the ratio test. We could also use the nth term test, which says to take the limit as n goes to infinity of the nth term, the a-nth term. So that's going to be the limit as n goes to infinity of n factorial times e to the negative n, which is going to give me, again, the limit as n goes to infinity of n factorial over e to the n. And when we evaluate this, we're going to get infinity over infinity. And so this is a limit that fails to exist. And theorem 6 says that if the limit fails to exist, that's also going to mean that the series diverges.